Today, we're going to look at some piecewise defined functions and talk a little bit about some FRQ type questions that we'll see on the AP test. So it's fairly common on the AP test for them to give you the graph of some function, which in this case we've called f of x. So this is the graph of f of x, which we know to be the derivative of some other function g of x. And we've defined g of x as the integral from -7 to x of f of t dt, which makes sense here to note that g prime of x is equal to f of x by the first part of the fundamental term of calculus, with the derivative of an integral from a constant, -7, to x of some function is just the function. And so this is just the first part of the fundamental theorem of calculus that we're looking at. And so what it's asking us to do is define g of -3. And normally they'll define these, I haven't written it here, but they'll say, oh, this is a piecewise linear function. Or it may have some extra shapes in there. They'll define things so that you know for sure that these are lines. And so this is a piecewise linear function, and we're looking for g of -3. Well, g of -3, if I just plug -3 into g of x over here, is just an integral from -7 to -3 of f. Well, in order to find that, we just need to look at the value of the area between the curve and the x-axis here. But keeping in mind that g is equal to an integral, not just the area. So that means that this section that's below the x-axis needs to come out to be negative. Since it's a triangle, we'll do 1/2 the base, which extends from -7 to -3, so 4 units, times the height, which is clearly 2 from 0 to -2. And this ends up giving us -4 as our value for g of -3. If we're asked to find g of -2, well, g of -2 is just the integral from -7 to -2 of f of x dx. Right? It's everything we'd already done in red, plus this extra little sliver here in blue, another little triangle. But we don't actually have to recalculate that first piece of the integral, right? From -7 to -3, we already knew it was -4. And then we'll just add to it the part that is from -3 to -2. So that'll be -4 plus, and this time we're above the x-axis, so that triangle's area will come out to be positive value. 1/2 of the base, which is from -3 to -2, is 1. And the height, which is from 0 to 4, 4, which gives us -4 plus 2, or -2. Here we've got the same graph. And so we're going to use that other information that we had before, that we knew that g of -2 was equal to -2. That's what we just found a second ago right here. G of -2 was equal to -2. And so we're going to use that information to help us find g of 4 and g of 8. And because g of 4 is just an integral from -7 to 4 of f of x. And we know that from -7 to -2, it's -2. So it should be -2 plus the integral from -2 to 4 of f of x dx. So we'll just find all of the chunks from -2 to 4. Well, from -2 to 0, that's a trapezoid. So that'd be base 1, which is 4 units here, plus base 2, which is 2 units. Divide that by 2, because that's how we find the area of the trapezoid, and multiply it by the height of 2. And then we're going to do that same thing again right here. This is actually the exact same trapezoid, just reflected over, get us all the way over to 2. So that'll again be 4 plus 2 divided by 2. Times 2, And then we'll add to it this last section to get us all the way over to 4, which has a height of 4 and a base of 2, but it's a triangle, so it'll just be 1/2 of 4 times 2. And if we add all those together, 4 plus 2 is 6. And if you divide that by 2 and multiply it by 2, that's 6 again. And so we got -2 plus 6 plus another 6, which is 10. And then we'll add 10 plus 4 over here with a 1/2 4 plus 2, which gives us 14. To find g of 8, we're just going to call that an integral from -7 to 8 of f of x dx. And we'll say that's 14, the value all the way up to 4, plus whatever our integral from 4 to 8 of f of x dx is. And that integral is this value of the area of this triangle, except it's below the x-axis, so it'll be negative. So we have minus 1/2 of the base, which is 4. And the height, which comes straight through there, is also 4. So we've got 14 minus 8. 14 minus 8 is 6. And so the value of g of 8 is 6. This one is the same graph that we were just looking at a second ago. But this time we've defined the function g of x as the integral from 0 to x of f of t dt. Right? It's defined slightly differently. Instead of being the integral from -7 to x, it's the integral from 0 to x. And the graph we're given is still f of x, and f of x is still the derivative of g of x. So if we want to find the value of g of -3, we just plug it in up here. G of -3 should be the integral from 0 to -3 of f of x dx. Well, normally when we do our integrals, we go from left to right, but this is telling us to go from 0 to -3. So in order to make this an integral that we're used to, we're just going to flip the limits of integration using that integral rule that says we can do that as long as we put a negative sign out in front. So the integral from 0 to -3 of f of x dx is equal to the opposite of the integral from -3 to 0 of f of x dx. And that's this section right here. Put a negative in front so we don't forget. And that can be broken down into this little triangle here and the trapezoid over here. And so the triangle is 1/2 of the base, which is 1, times the height, which is 4. And we'll add to that the trapezoid that we already found. It had a base of 4 and a base of 2, divided by 2 times the height of 2. And so we end up with negative whatever we've got inside of here, which is 2 plus 6. So we got -8. So the value of g of -3 here, when g of x is defined as the integral from 0 to x of f of t, is -8. To find g of -5, we just want to find an integral from 0 to -5 of f of x dx. Well, that should be the opposite of the integral from -5 to 0 of f of x dx. So we'll just do negative, and then from -5, -7, from -5 right here to -3, that little bit has a base of 2 and a height of 1, and it's below the x-axis, so it's going to be -1/2 base times height. And then we'll continue to add to that these other two values that we just found here. One of them was 2 and the other was 6 for the triangle right here and the trapezoid right next to it that gets us back to 0. And so now we've got negative, then inside of here we have a -1 plus 2 plus 6, so -1 plus 8 is 7, and we end up with -7 as our final answer. Here we're looking at the same graph again, and we know that it's the graph of f of x. And we know that the derivative of g of x is f of x, same thing as before, but also that g of -2 is equal to 3. So instead of them giving us an integral this time, we worded it slightly differently, where that g of -2 is equal to 3. So because we know that g of x is some antiderivative of f of x, we should be able to come up with a function to represent g of x. We know that g of -2 is 3, which means that the integral of f of x dx from -2 to some value up here, we'll call it t, needs to be a piece of our integral. But anytime we're going to some other value, we're going to have to add 3 to it. Right? So we're looking at 3 plus an integral from -2 to some t value for each of these g's that we're going to have to try to find. You can kind of think about it like the integral could start somewhere. You know, it's going to start at -2, and we're going to just kind of go from there. Let's say we started over here. To get to -2, we're going to say that would somehow, between whatever was over here and what we got here, the total value for that integral ended up being 3. And so as long as we go from -2 to anywhere else and add that 3 to it, we should be able to just find these values. So let's do that. If we want to find g of -3, it should be our initial condition plus an integral from -2 to -3 of f of x dx. So the integral from -2 to -3 is actually going backwards. We don't want to do that. So we'll flip that integral and make this 3 minus the integral from -3 to -2 of f of x dx, which is 3 minus 1/2 of that base, which is 1 still, and the height, which is still 4. So we end up getting 1. So the value of g of -3 is just 1, which should make sense because if we integrated from over here somewhere to get all the way to -2 and it was equal to 3, well, if we didn't quite go that far, we should be subtracting off this amount, which was that 1/2 base times height, that value of 2. And if we want to find g of -7, g of -7 ought to be 3 plus the integral from -2 to -7 of f of x dx, or 3 minus the integral from -7 to -2 of f of x dx, which is 3 minus, and the integral from -7 to -2, well, the -7 to -3 piece of it is below the x-axis, so -1/2, the base of 4, we've done that triangle before, and a height of 2, and we'll add to that the little piece that we just found here, the 1/2 base times height for this triangle, which we've done quite a few times, that's just 2. And so we end up with, inside of our brackets there, -1/2 of 4 times 2 is -4. negative 4 plus 2 is negative 2, and 3 minus negative 2 ends up being 5. And so as we move backwards, we lost a little bit of the value of g as we got to here, but as we continued back to the left, we're now gaining area because this stuff was negative. So going backwards with a negative should increase the value. So let's do a couple more of these. This one's the same function again, same graph, but we're given that g of 2 is equal to 1. And so if g of 2 is equal to 1, and we know that f of x is a derivative of g of x, and we want to find the value of g of 8, well, g of 8 ought to just be the value of g at 2, which is 1, plus the integral from 2 to 8 of f of x dx. And we should note that, if we were to think about it like we're starting all the way over here. We got some integral all the way over here to 2 that ends up equaling 1. And if we then want to go the rest of the way to 8, it's just whatever it was from wherever we started here. It's 1 plus whatever's, this area and this area. So that's what we're going to do. We've got 1 plus the integral from 2 to 8 starts out as a positive value, 1/2 of the base of 2 and a height of 4. And then we'll subtract 1/2 the base of 4 for this other triangle that's below the x-axis from 4 to 8 times a height of 4. And we've got 1 plus 4 is 5. And 5 minus 8 gives us negative. And then to find g of negative 7, this ought to just be 1 plus the integral from 2 to negative 7 of f of x dx, or 1 minus the integral from negative 7 to 2 of f of x, so that we can go from left to right, which is 1 minus from negative 7 to positive 2. We've done all these before. This piece right here is below the x-axis. That's negative 1/2 base times height. And again, that one's negative 4. So I'm just negative 4. We've done that a bunch of times. This one right here, 1/2 base times the height there. That's just 2. So put that up there is plus 2. And we've done these trapezoids a few times also. That's base 1 of 4 plus base 2 of 2 makes 6. Divide that by 2 is 3, multiplied by the height of 2 brings you back to 6. So plus 6 for that one, plus another 6 for that one, which gets us all the way to 2, which is where we're trying to get to. And inside of this, we've got negative 4 plus 2 is negative 2. And negative 2 plus 6 is 4. And 4 plus another 6 is 10. So we have 1 minus 10, which is negative 9. And this is the last one of these that we're going to do. And so this time we've got a different looking function. I'm going to tell you that this is piecewise linear with 2 semicircular sections. And they'll always define that. These are both semicircles. Right? These chunks from negative 2 to 2 and from 4 to 8 are semicircles. And so if we want to find g of 8, knowing that this is f of x and f of x is the derivative of g of x, and we know that g of 2 is equal to 1, then to find g of 8, we just need to do the value of g at 2 plus however much we add in between 2 and 8 as an area underneath this curve. And so if we think about that, from 2 to 4, we're looking at a triangle. So we have 1 plus 1/2 the base, which is 2, times the height, which is 2. And then we're going to add in some more area underneath this curve, this piece. But that piece is actually what's underneath the semicircle. So we got to think about that one a little bit differently. This is a full rectangle, and we are subtracting this semicircular region out of it. So the full rectangle is a base of 4, from 4 to 8 with a height of 2. So 4 times 2. But we don't have that full thing. We have to subtract the semicircle, which is 1/2 pi times the radius of that semicircle squared. And our radius, it just extends from 6 to 8, so 2 units. And so if we put all of this together, we should end up, it looks like, with, we've got 1 plus 1/2 of 4, so that's 2. So 1 plus 2 is 3. And then 3 plus this 8 here is 11. And then it's going to be 11 minus, over here, 1/2 pi times 4 is 2 pi. So 11 minus 2 pi ought to be our value for g of 8. In order to find g of -2, we'll have to do 1 plus the integral from 2 to -2 of f of x dx, which is the same as 1 minus the integral from -2 to 2 of f of x dx, just using that rule where we can flip the limits of integration. And so we end up with 1 minus, well, the integral from -2 to 2, that's this semicircular region. This time it's actually the area of the semicircle. That's the part under the curve. So that's 1 minus 1/2 pi times the radius, and this one again has a radius of 2. So 1/2 of pi times 2 squared. And that just gives us 1 minus 2 pi. And for our last one down here, we should have 1 plus an integral from 2 to -6 of f, which would be the same as 1 minus the integral from -6 to 2 of f of x dx. So 1 minus the quantity of the integral from -6 to 2. Well, from -6 to -5, we've got a positive 1/2 base of 1 and height of 2. And then from -5 to -2, we have a triangle that's below the x-axis. So we'll subtract 1/2 of that base of 3 times a height of 2, base of 3 and a height of 2. And then we just found a minute ago that this semicircle right here had an area of 2 pi. So we'll add 2 pi into that. It's above the x-axis. And inside of here, looks like we end up with 1 from the 1/2 of 1 times 2. And then 1 minus 3 is -2. So inside of here, we've now got -2 plus 2 pi. And so we have 1 minus -2 plus 2 pi. 1 minus -2 is 3, and then minus the 2 pi just gives us 3 minus 2 pi. And that's our final answer for g of -6. And so you'll definitely end up seeing something similar to this in what I call a graph FRQs on the AP test. They're always non-calculator questions. And then they're going to ask you to do some other assorted things with them that we'll talk about if we get a little bit more in depth with the FRQs. But that's going to do it for today. Next time, we're going to start our conversations about volume. And volume is our last topic before we just go into full-blown review for the AP test. So that's it for today.